Alright, here we go with another lesson in trigonometry. And this one is on reference angles and special angles. So you'll remember from the last lesson that a reference triangle was what we got when we dropped a perpendicular from the point on the unit circle to the x-axis. So maybe it won't come as a big surprise to you that a reference angle is the measure of any angle also from the x-axis. So let's draw in these angles that we're given here. So sine of 40, we'll just draw in where would 40 be. Let's see, 40 is a little bit less than 45. Whoa, what happened there? Let's try that again. 40 is a little bit less than 45 would be here. So 40, let's say, is about here. So this would be in standard position 40 degrees, approximately. Then if we look at the next one, I've got 140. Well, let's think. All the way over here, that would be 180. So 140 is going to be 40 less than that. So that's going to be something like this. So all the way this part is 140. But this part right here, measured from the x-axis, is also 40 degrees. What do you know? Then we want to draw a sine of 220. Think about that. That's going to be 180 plus an extra 40. So that's going to be 40 below my axis, something like that. And so again, all of this thinking standard position, that would be 220. But just this part here, measured to the x-axis, well, that's going to be, again, 40 degrees. And then last but not least, we want to draw 320. So 320, well, that's 40 less than, this would be all the way to here would be 360. So that's 40 less than 360. So we're going to end up being somewhere down here as well. So again, all the way around, this would be 320. But what we're really interested in is the fact that this section here is also 40 degrees. So again, my reference angles are always measured to the x-axis. So could be the positive x-axis in quadrants 1 and 4. It could be the negative x-axis in quadrants 3 and 2. So once we've drawn those in, you get that idea. What happens when we take out our calculator and take the sine of each of these angles? What are we going to get? So we'll let your handy dandy calculator and just type in sine of 40. Well, that gives me this kind of funky decimal, 6427 whatever, 0.6, oops, let's do this in a different color, 0.6427 dot 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 is what we get when we type in that first sine. And when we type in sine of 140, oh, look at that. We get exactly the same decimal, 0.6427. Keep going, keep going, keep going. I know I'm not actually rounding. I'm just telling you it keeps going after that point. So if I did round, that would be 628, something like that. Okay, and let's try sine of 220. That gives me, oh, same decimal but negative. Look at that, negatives 0.6427 keeps repeating. And can you guess what the sine of 320 is? And that's our last one that's kind of hidden behind the calculator there. Sine of 320, you guessed it, negative 0.6427. Let's put our calculator away so you can actually see that. So, in other words, when we have the same reference angle, so all of these angles have the same reference angle of 40, we got the same trig ratio, we got the same decimal when we typed in the sine into our calculator. And you would find the same thing if you typed in the cos of each of these angles, or the tangent of each of these angles. The sign may vary, some are positive and some are negative, but the actual trig ratio, the actual decimal that you get is going to be the same for every single angle that has the same reference angle. Kind of cool. That's going to come in very useful as we continue in this unit. So next section, find the reference angle. What is it going to be? So in the first picture, I have 150 degrees drawn into the second quadrant, and I know up here this is 90, all the way over here this is 180. So 150 degrees to get to 180 degrees, this bit here, which is our angle measured to the x-axis, is going to be 30 degrees. That would be my reference angle. 30 degrees is what I'm looking at for a reference angle. So again, measured to the x-axis. Think, okay, this is not the same as standard position, which is always to the positive x-axis and always counterclockwise. It's just this amount, and it's always going to be a positive number. negative 100 degrees. So in order to do this, I am going to actually draw my own picture. So quickly sketch in a set of axes, and negative 100 is going to go backwards, so it's going to go downwards first. This would be negative 90 and negative 180. So negative 100 is going to be just beyond negative 90. So that would be my angle drawn in standard position, negative 100. But my reference angle, which is what I'm looking for, is again drawn to the x-axis. So how much farther would I need to go to get to negative 180? That would be another 80 degrees. So that would be my reference angle. And again, it's always going to be given as a positive number. Doesn't matter that I would need to go 80 degrees clockwise, which is a negative rotation. It's still going to be a positive 80 degrees for a reference angle. And can we do this as well in radians? We sure can. And again, let's draw ourselves a set of axes to work with. And I need to figure out where 23 pi over 12 is going to be. So if I think about, okay, this is 0 pi over 12, this is pi over 2. Pi over 2 in terms of 12, this is going to be 6 pi over 12. This is going to be 12 pi over 12, so we got to keep going. This is going to be another 6. This is going to be 18 pi over 12, all the way up to 24 pi over 12, which would be my 2 pi. So 23 pi over 12 is just a little bit less than the 24 pi over 12. So we'll draw that in something like this. So all the way around here, this is my 23 pi over 12. And what I'm interested in knowing is how much this little bit left over is going to be. So if I went all the way to 23 pi over 12 and knowing to get back to the positive x-axis is going to be 24, this little bit in here must be pi over 12. I just need one more. 23 plus 1 is 24. So one more pi over 12 to get my reference angle. So really not a big deal in radians either. We can do those no problem. Okay, there are some angles that are considered special angles, and these ones you will need to have memorized eventually, because you need to be able to give the exact values for your trig ratios and not just decimals from your calculator. And so the first of these, which we've seen before, is a 30-degree angle, which is going to end up being somewhere over here, 30 degrees. And we're talking in the unit circle, so my hypotenuse is going to be 1. And I'm going to draw in my reference triangle to figure out what my points are going to be. So drop a perpendicular line from the point on my unit circle to the x-axis. And again, you're going to need to memorize these. This short side is half as long as my radius, so this is going to be 1/2. And you could use Pythagorean theorem or memorize that this bottom side is going to be √3/2, which means that this point right here on the unit circle has coordinates √3/2, 1/2. And now how does that help me out? Well, if you remember on the unit circle, every point I have is cos of that angle, sine of that angle. So if I want to know what is the cosine of 30 degrees, cosine of 30 degrees is √3/2. And I can also see that thinking about SOHCAHTOA from my reference triangle, cosine would be adjacent over hypotenuse, or √3/2/1 is just going to be √3/2. So again, unit circle, and only the unit circle, I get cosine from my x-coordinate and sine of 30 degrees from my y-coordinate. If you want to test that out, you could pull out your calculator. The one that would be easiest to test out would be the sine, because that should give me an exact decimal. So sine of 30 degrees, and it does in fact come out as 0.5, which is 1/2. So that's good, just have that little bit of confirmation. Okay, so that's one of my special angles. The second special angle that I'm looking at is 45 degrees. 45 degrees. And again, I'm going to drop a perpendicular to get myself a reference triangle. And in the unit circle, I know my hypotenuse is 1. And in order to get these two sides to be exactly the same, and yet to fit the Pythagorean theorem of a² plus b² = c², turns out these guys have to be both √2/2. √2/2, which gives me the point then, √2/2, √2/2. So again, these guys have to be exactly the same, because a 45, 45, 90 triangle is what do we call it? Isosceles has two sides the same, and the hypotenuse is still going to be 1. So again, if I wanted to say, whoops, I forgot to label this. This is 45 degrees. If I wanted to say what is the cosine of 45 degrees, I'd look, okay, here, cosine is adjacent over hypotenuse is root 2 over 2, or I would look at the point on the unit circle, which is root 2 over 2. Okay, so that is my second special angle, and my last special angle is actually very much related to this first one, is a 60-degree angle, which is going to end me somewhere up here. This is going to be 60 degrees. Drop the perpendicular again to get yourself a reference triangle. Whoops. Let's try that again with a straight line. Straight line, 90 degrees. And like before, hypotenuse is 1. Short side, just like on my 30-degree triangle, my short side is a half. But this time it is now on the x-axis. And my long side is root 3 over 2 to get me the point 1/2 comma root 3 over 2. And again, you could say, okay, what is the cosine of 60 degrees? Well, cosine is adjacent over hypotenuse, ka. So 1/2 over 1 is just 1/2, or it's also the x value of my point on my unit circle. Okay, so you're going to use these so much that you have them memorized. You may need to practice drawing them out a couple times so you know exactly what they look like. They're going to be the same every time. If you can't remember which one is which, you can always type it into your calculator and see which is shorter, 1/2 or root 3 over 2. And for these ones, it's always root 2 over 2 for both of them for the 45 degrees. Now you do need to be able to recognize these in radians as well. So 30 degrees is pi over 6 radians. Let me pick a new color. So 30 degrees is equal to pi over 6 radians. And the way that I remember that is pi is just 180, and 180 over 6 is 30. So I go what divided by 180 divided by what gives me 30, and that's going to be pi over 6. Now 45 degrees is equal to pi over 4, and again 180 divided by 4 is 45, and 60 degrees is pi over 3, because what 180 divided by what equals 60, 180 divided by 3 is 60, so that gets me my 60 degrees. So you need to be able to work with these in both degrees and radians, but the sides will be the same every time. You just need to remember which triangle goes with which. Okay, so you will get fast at drawing in the unit circle with your reference angles, reference triangles, and then using the points to find cosine, sine of different angles. So let's try the ones that are given here down below. I want to know what is the cosine of 120 degrees. So 120 degrees, well, let's think. That's going to be somewhere up here, 120, which gets me the reference angle, reference triangle of 60 degrees. So over here we got 60. And then I know, okay, this is going to be 1, this is going to be a half, this is going to be root 3 over 2. And I'm looking for the cosine. So from here, the adjacent side is 1/2. Now, there is one more thing we need to keep in mind, and this is what we talked about last class in terms of which things are positive in which quadrants. So you can remember, if you want to, hang on a second, this is going in on the negative x-axis, so this is going to be negative 1/2. So his final answer is actually negative 1/2, but it's a positive on the y-axis, so it would be a sine of plus root 3 over 2. If you want to remember where we are, what this actually means, or this is the coordinate negative 1/2 root 3 over 2, and from there figure out this is cosine and sine. Or you can also have memorized that mnemonic that we talked about. All students take calculus. And so in this case, sine is the only thing that's positive in this quadrant, so cosine must be negative. You can remember it that way as well. Just depends which makes more sense to you, which you want to use. So the next thing we're looking for is sine of 210. So let's think, this is 180. So 210 is going to be 30 degrees more than 180, so that's going to end me up down here with a 30 degrees here. And again, I'm going to drop my perpendicular to the axis to get me my reference triangle. So in terms of this one, I've got a 1 on my hypotenuse. The short side is a half, and the long side is again root 3 over 2. and I'm looking for the sine of 210. So the sine is going to be the opposite, is also going to be 1/2. Look at that. And in this quadrant, only tangent is positive, so sine must also be negative. And I know that as well because this is going to be on the negative y direction and also in the negative x direction, which is how I get to be positive for tangent. Now, tan of 315 degrees, pretty much every single time you get a 5, and we're talking special angles, it's going to be one of those 45-degree angles. So 315 is going to end me up in this extra quadrant 4 over here. Drop in your perpendicular, and you're at root 2 over 2 and root 2 over 2. They got to be the same. And 1 on the hypotenuse. So if I'm talking tangent, remember tangent, here's my 45. Tangent is opposite over adjacent, or y over x, depending on how you want to look at it. So this is going to be root 2 over 2 over root 2 over 2. Well, when you divide something by itself, or you can flip and multiply if you like, you're just going to get a 1. In this quadrant, ASTC, only cosine is positive, so this is actually going to be a negative 1. Negative, because this root 2 over 2, which was the opposite, is actually a negative y direction. Okay, so those are my three basic trig ratios. Now I'm looking at secant of 180. Well, hang on, 180 is going to put me right onto this axis right here. If I draw in a 180 degrees, this does not in any way get me a triangle. But it does give me a point on the unit circle. So this is going to be on the x-axis a negative 1 and on the y-axis 0. And actually these points all end up being quite nice like that. This is going to be 0 on the x, 1 on the y. This is going to be 1 on the x, 0 on the y. And this one is going to end up being, let me think, 0 on the x, negative 1 on the y. So these are all negative 1s and 0s. So secant of 180, remember secant is related to cosine. So if I can first find cosine of 180, then flip it over to get me secant of 180. So cosine of 180, well, cosine, remember, is going to be your x-coordinate. So here we are at cosine. So my cosine of 180 is negative 1. And flip that over, 1 over negative 1 is still just negative 1 for my secant value as well. So these quadrantal angles, these ones that end up on the exact axes, are actually not that big a deal. You just have to be careful that you remember that cosine is your x and sine is your y, and you're good to go. All right, let's do some that are exactly the same thing, but in radians. So I've got sine of 5 pi over 4. So thinking along here, this is going to be pi, which is 4 pi over 4. So 5 pi over 4 is going to put me down here in quadrant 3. That would be my 5 pi over 4. Drop the perpendicular to get me my reference triangle. And again, this is going to be root 2 over 2, negative root 2 over 2, because we go downwards, and a 1 on my hypotenuse. Here's my reference angle of pi over 4. And in that case, it's going to be, again, sine is opposite over hypotenuse, or negative root 2 over 2 over 1. So this is just negative root 2 over 2, which makes sense, again, with the negative. If you think ASTC, only tangent is positive in this quadrant, so sine must be negative. Cotangent of pi over 4. Well, pi over 4 is going to put us smack dab in the first quadrant. It is the 45 degrees in your first quadrant is my pi over 4. If I drop down my perpendicular, I'm looking at exactly the same triangle that I was looking at originally. So root 2 over 2 and root 2 over 2. And cotangent is 1 over tangent. So instead of being opposite over adjacent, it's going to be adjacent over opposite, but it's still root 2 over 2 over root 2 over 2, which is still going to equal 1. And I'm going in a different order in this case. I don't know why I decided to go down first instead of over, but there you have it. So there's my cotangent, and in this quadrant, all things are positive, including cotangent. Next one, cosine of negative 2 pi over 3. So negative 2 pi over 3 is now going in this direction. This is going to be negative 3 pi over 3. So negative 2 pi over 3 is going to end me in quadrant 3. It's going to get a little messy here. Hopefully with the other colors you can see what's going on. So again, drop our perpendicular. This is going to be a 1. The short side is the 1/2, and the long side is √3/2 with a negative because it's a negative y. Cosine is going to be the opposite from my reference angle. So reference angle is the pi/3. So this is going to be opposite is √3/2, and adjacent we don't care about. So negative √3/2. Whoops, √3/2. Over 1 is just negative √3/2. And the very last one we get to play with is another quadrantal angle. So 3π/2. Well, this is 1π/2. This would be 2π/2. So this down here must be 3π/2. Again, thinking about what my coordinates of my unit circle would be here, it's going to be a 0 for x and a -1 for y. So secant is related to cosine again. So I'm going to say, what is cosine of 3π/2? Well, cosine of 3π/2, again, it is cos sine, c before s, x before y. So cosine is 0. So when I flip that over, I've got 1/0, which is, oh no, I can't divide by 0. That means we must be undefined. The value does not exist. So you can get undefined values. That's not a problem. It's when you divide by 0, you get undefined. Right, so you'll get really good at drawing in these unit circles with the reference triangles and finding your exact values. So for this next exercise, we are actually going to find all 6 trig functions using our reference triangle and the unit circle. So draw in 30 degrees on your unit circle. So that's going to be somewhere over here. And drop down your perpendicular to draw in your reference triangle. So unit circle, hypotenuse of 1, opposite side is half as big, and the long side is √3/2. This gives me the point then with coordinates √3/2, 1/2. So that's the first thing. I'm just going to draw in my unit circle and label, here's my 30 degrees. Now the next part asks me, what is 30 degrees in radians? Well, 180 divided by what is 30? 180 divided by 6 is 30, so this is also going to be then pi/6. Sine theta, you could either go, okay, sine is opposite over hypotenuse, or you can go, like, the point is cos comma sine. In either case, you're going to get sine is 1/2. Cosine adjacent over hypotenuse, or it's the x-coordinate is √3/2. Tangent theta is opposite over adjacent, or you could also say it's sine over cosine. So tan of 30 degrees, if I go opposite, is 1/2 over adjacent, √3/2. And we want to simplify that out by flipping to multiply. So this is 1/2 times 2/√3. And I'm going to cancel out these 2's. So I get 1/√3. And I'm not done yet because I don't like having a radical on the bottom. I've got to rationalize that denominator. So multiply top and bottom by √3/3. It's going to get me, final answer, √3/3. So there's my tangent. Then I look at cosecant, which is 1 over sine, or flip sine over. So 1/2 flipped over is 2/1, or just 2. Secant is cosine flipped over. So instead of √3/2, it's going to be 2/√3. The unfortunate thing about that is that we've got 2/√3 also has a radical in the denominator. So I'm going to need to rationalize that by multiplying by √3/3. And that gets me 2√3/3 is my final answer. And cotangent is a flip over tangent. Whoops, I wrote √3/2. This should be √3/3. I am sorry. I'm going to flip that over. So cotangent of 30 degrees is going to be 3/√3. And again, I'm going to need to rationalize that. So multiply by √3/3 gets me 3√3/3. And I can simplify those 3 and 3 to just get me √3, which actually makes sense if you go back to this stage where we said tangent was 1/√3. If I flip that over, I would have just got √3. So if you can see that right away, you don't have to go through the whole process. But if you don't remember that, it works the other way as well. This last part is asking us what would happen if we rotated in the negative direction. What would be our degrees? So if we went downwards from our x-axis, what degrees would this angle be? So all the way around, this would be to negative 360. So I'm short 30 degrees. 360 minus 30 is 330. So this is going to be then negative 330 degrees. And negative radians. Now I'm thinking, okay, all the way around, I'm thinking this is I want a denominator of 6. So this is going to be negative 12 pi over 6, negative 2 pi with a common denominator. And this is pi over 6. So I'm going to be short 1 pi over 6. So this is going to be then negative 11 pi over 6. Why don't you pause your video now and try this next one that starts you out in radians of pi over 2. Then come back and check and see how you did. So I just cleared that all out so I could have a little bit more space. Hopefully yours doesn't get too confusing. So pi over 2 radians is 90 degrees. Sine is going to be my y value and cosine is my x value. So this is cos comma sine. So I've got sine as 1, cosine of 0. Now tangent is sine over cos or y over x. This ends up being then 1 over 0, which is undefined. Cosecant, 1 over sine, well flip over 1 is just 1, so 1 over 1 is still 1. Secant flip over cosine is also going to be undefined because the 0 ends up on the bottom. Cotangent is flip over tangent, so I had 1 over 0, that means flip it over, I get 0 over 1, which is allowed. So cotangent of 90 degrees is going to be 0 over 1 because I'm flipping over this fraction, which is just equal to 0. So cotangent is equal to 0. Negative degrees, we're going around this direction, so this is going to be negative 270. And negative radians, again, this is going to be pi, which is 2 pi over 2, and this is going to be 3 pi over 2 in the negative direction, so this is negative 3 pi over 2. The last thing we're going to take a look at doing is actually working backwards. In these cases, we were given an angle and we wanted to find the trig ratios. Now we're going to be given a trig ratio and we need to actually find the angle. And it turns out between 0 and 360 degrees that many of these will have at least, well, most of them will have 2 that actually fit the bill because we know that our sine is going to be the same for everything that has the same reference angle. So where is sine theta equal to a half? Well, this is essentially asking, remember that my unit circle has the point cos comma sine. It's asking me, where do I have 1/2 as my y coordinate? In other words, I'm up here, halfway up my unit circle. Here would be 1/2. That would be this point here. So let's draw in my triangle. Y coordinate of 1/2. And hopefully you recognize this as being the 30 degrees. We're talking in degrees, or pi over 6 would be the reference angle. So this is theta equal to 30 degrees. That would be one option. But a y value of 1/2 also corresponds to this point over here, which would go out like that. I could draw in my reference triangle here, and this is also 1/2. This is also 30 degrees. This is also root 3 over 2, but negative. Now, I can't just put 30 degrees again because in this case, this is my reference angle, it's not the angle itself. So to find the angle itself, I need to go all the way from my x-axis. I'm asking myself, what would this angle be equal to? So all the way to here would be 180, and I'm 30 short of 180, or subtract 30 from 180 is going to be my second answer of 150. Where is cosine equal to a half? Now this is asking, where do I have an x-coordinate of a half? So x-coordinate of a half would be right here. 1/2 is going to correspond to this point up here, which in my first quadrant, this is a 60-degree angle. In the first quadrant, my reference angle is going to be my angle, and it also corresponds to this point down here, which has a reference angle of 60 degrees. 100% does, but what I'm looking for as my answer is going all the way around to here. So I know if I went all the way and finished off the circle, I'd end up at 360 degrees, but I'm 60 short of that, so that is going to be then just 300. So you can draw in the full triangle if you want, if you need it, if it helps you to figure out where exactly you're looking at. In this case, I think I drew it a little bit off when I'm going for a half, but that's the idea. Where is tan theta equal to -1? So remember that tan is y over x. In other words, we're asking where our y value and x value are going to be the same, but one of them positive, one of them negative. Well, that happens at all my reference triangles of 45 degrees, but only in certain quadrants. So this is where I like to use the ASTC, and this tells me tangent will be negative in S and C. It will be positive where tangent is positive and positive where all are positive. So if I'm drawing in, this is my 45-degree angle here, 45, because that's the one that has both x and y being the same. So when you divide them out, my √2/2 and my -√2/2 would divide to get me -1. And same thing is going to happen down here in quadrant 4. Again, I've got to have one positive, one negative. So in this case, I've got a -√2/2 on my y and a positive √2/2 on my x. And this is also going to be 45 degrees over here. So we know we're looking at a 45-degree reference angle, but what are my actual angles? So this one here, getting a little crowded. I might have to delete some of this in a minute before we go on. So going all the way over here, all the way to here would be 85. So 85 minus 45 is going to be, theta is 135. And all the way around to here would be, well, 360 minus 45 is going to be 315. Okay, let me clear some of this out so we can do the last couple. So if sine theta equals √3/2. So this is going to be then the point where, again, my x value is √3/2. My x value is going to be somewhere way over here, because I know this one is √2/2. This one would be a half. This is √3/2 here. So I'm going to draw in my reference triangle. Again, this is going to be, oh look, 30 degrees. And I've got, again, √3/2. Hang on, is that right? Did I mix this up? Yes, I mixed this up. Sorry, it should be the y value is √3/2 because sine is my y value. I don't know why I looked up here and said sine was my x value. Sine is my y value. So that's going to mean a y value up here of √3/2, which is almost 1. So we're actually looking at a reference triangle of 60 degrees, which is going to have, again, √3/2, 1/2, and 1 on the hypotenuse. So 60 degrees. We're in the first quadrant when sine is positive. This is going to be, first answer is just 60 degrees. And the other place where I'm going to have a y value of √3/2 is going to be in the second quadrant. Again, √3/2 is still going to be positive in this quadrant, 1/2. And so I've got, if you wanted to double check, ASTC, these are the two quadrants where sine is positive. So I've got, again, the 60 degrees as my reference angle, and I'm looking for what would get me all the way over here. So all the way to here would be 180. So 60 degrees short of 180 or less than 180 is just 120. 2 more to go. Cosine equals 0. So cosine is where my x value equals 0. That's going to happen on these two quadrantals. One up here, this is going to be 0, 1. And one down here, this is going to be 0, -1. So what are my actual angles here? Well, this first one is theta equals 90 degrees. And this one down here, all the way around, is 270. Last one, where is cotangent theta undefined? Well, undefined means I'm going to be dividing by 0. So I'm looking at something like 1/0. And remember that this is, well, this is flipped over from tangent. So actually, let's say where this would be where tangent theta is actually equal to 0. Because if I flip it over, then I'm going to get undefined. And tangent theta is y over x, or cos over sine. So I need a y value of 0 and an x value of something else. Well, my y values of 0, those ones happen here. This is a y value of 0, x value of 1. And over here, -1, 0. So these are where my y values are going to be 0, so that when I flip this over, then I'd get an undefined for cotangent. So those angles would be theta equal to 0 degrees, or 360, and theta equal to 180 degrees. And that's it, all done. So there is a lot of practice for you to do, because you need to get really good at these. You need to be good at drawing in these triangles. For the practice, you need to draw in your own triangle. I would not recommend just having one out that you've drawn already to reference for later. I would recommend drawing them pretty much every single time just so you get good at drawing them. So you get good at knowing which numbers go where and what you need. Good luck with your homework and your mastery quiz.